Good morning, everybody. Yeah, break glass accounts is one of the most undiscussed things within cybersecurity, I do believe. I've been working with organizations for the past 20 years. In the last 10 years, a lot of that has been focused upon the cloud. As Eric very kindly mentioned, yeah, I've been at SANS for 7 years. It's like that anniversary came up. That's definitely the longest job I've ever had. And it's one of the coolest, actually, as well. I get the benefits of essentially building out environments that nobody else would have the requirement to build. We have to build systems that are specifically vulnerable to attack, that are hardened to the nth degree. And then we invite 400 to 500 hackers at a time to come in and break it and show us how wrong we are. That's a pretty interesting job. So as Eric kind of mentioned, yeah, SANS, I run the R&D effectively in EMEA. 2 jobs in SANS, 2 different time zones. So I don't get much time to do anything else, really. The technical architect for ranges, I build the CTFs. If you've ever played anything in SANS, CTF-wise, the chances are you'll have played some of my content. So either you really enjoyed it or I'm sorry. I am also, because I'm an instructor, and SANS doesn't class building CTFs as being a practitioner, which is a requirement to be an instructor. They give me dispensation to run my own company as well. So I've got a whole host of different small businesses, anything from the smallest about 85 staff to about 400. And I operate at different levels of security architecture, or I'm VC, so for a couple of them, and I'm on a few boards as well. And that keeps me pretty busy. And on top of that, I've got about 4 acres of land, and I grow squirrels and dandelions. Otherwise, I spend most of my time focused on cybersecurity. Now, one of the big things that I've seen and talked about with organizations over the last 2.5 years, this has come up repeatedly, is how do we handle root accounts? And how do we handle things like break glass accounts? Now, prior to my time with SANS, I worked for a SOC as a service company where I was effectively employee number 3 to begin with. When I left, there was 49 or so, but I was essentially the principal engineer. And the principal engineer responsibility was everything. I had to essentially engineer the SOC. I had to work with the sales team. They would sell things that didn't exist yet. And one of those challenges that we always came up with was, what do we do with root accounts? And how do we manage them from a security operations perspective? So we'll just rewind a little bit and actually understand the core problem that we have with root accounts. And that can be answered by one simple question that my previous boss asked me. Joined me at a conference once. He said, "Si, how do we recover from a lost root account?" I was like, "It's simple. Not your account anymore. You're just responsible for paying for it. So if they're going to mine Bitcoin from your AWS services, well, you'll get a big bill for it. But as far as you're concerned, it's no longer your responsibility because the root account has access to everything. It is the God level account. And with that level of capability within the cloud platforms, anything is possible. You can build shadow IT, change the entire structure of the policies in the accounts. You can do absolutely everything. So they have to be protected with the utmost sensitivity. They're often unsecured and mismanaged. The consequences are disastrous. Yeah, you lose a root account key, problem, it's no longer your account. And a lot of the breaches in organizations are based around authentication. So losing that root account is one that you definitely don't want to have a problem with. Now, the root account in AWS is pretty simple. It's an email address. That's it. And it sits outside of IAM. It's not constrained by policy. And if you have a root account access to an AWS account, you can take that account out of the AWS organization. So rather than having to steal the data, you steal the account. And you literally take a walk away with it, with everything that's included within it, which can include things like S3, workloads, everything, keys, the lot. In Azure, it's a little bit different. In Azure, it's an account that ends in .onmicrosoft.com. I'm going to ask you a bit of audience participation. Who logs in with an account that ends in .onmicrosoft.com? 1 or 2. That's it. Now, that means one or two things. That means either you hold the root account keys to the organization, or you have no domain set as the primary domain inside Azure. Which is it? The onmicrosoft.com domain names are the ones that are hunted out across dark web forums, where inside breach lists, they are the ones that are hunted and identified. And if they're identified, they are utilized. And those attacks are utilized against organizations extensively. The other type of account are ones that we create ourselves to effectively undo some sort of a breach or a problem. And these are our emergency access accounts. Emergency access, they're great fun because they're often sit outside of other policies. If we get an attack against an organization, you don't want your break glass account to follow the same rules as every other account inside the organization. Because if they do something like disable multi-factor authentication, then you are therefore locked out of your account. I've had a couple of situations with clients over the last few years, where organizations have actually been locked out of their own services. And this is kind of weird because it shouldn't happen. And the technology is there to defend against it, but it's just not utilized particularly well. The reason there are so many of these root accounts out there now is cloud adoption is still growing. There was a really interesting article actually in the Register the other day that said organizations are moving away from the cloud to a degree. And it's true, they are, because they've realized actually it's incredibly expensive and there is types of workloads that don't really fit the model of cloud services. But this the result of this is every organization ends up in a hybrid model. And this is as problematic as being purely cloud or purely on-prem. The Amazon account. Now, you may have heard this story before. In fact, if you were sat in the bar with me last night, you definitely have heard this story before. I was working with an organization who had an incident. And as part of that incident response, they said, we need the root account for this AWS account. We're getting locked out of it. There's problems with the identity services. We're not really sure who's in there, what's going on. We need access to the root account. Where is it? They said, it's in the CEO safe on a USB stick. So they went to the CEO safe, retrieved the USB stick, and they plugged it into the machine, and it was a collection of pictures. And the collection of pictures, when the CEO peered over the engineer's shoulder, was, that's my son's graduation photographs. My wife will be really happy we found those. At which point the organization went, yeah, but this is supposed to hold the key to the account. Where is it? And he looked a little bit sheepish and wandered off and just said, is it fixed yet? Okay, this actually happened. There is an organization who a friend of mine works for, where the root account for their for their AWS services is the CEO's Amazon Prime account. It's where they buy their dog food and the socks and things like that. It's also the root account for a company that transfers about $900 million a year in microtransactions. Root accounts are not handled well. They are mismanaged. And where they are managed well, there is not much monitoring. A couple of things that we have. There's an over-reliance on the root account to act as the break glass. I've seen this numerous times. Organization in the throes of an incident, you ask them for a break glass account, and they go, oh, we haven't got any of them. Well, we've got the root key. You think, that's insane. Why do you only have one account that's going to get you out of this situation? You should be prepared. The first step in every incident response process is be prepared, prepare. There are incomplete protections. The root key is stored on the USB chip in the CEO's safe, or it's the CEO's Amazon account. Or in fact, somebody has it and left the company. Yeah, user lifecycling is problematic enough. Never mind taking root keys with you. There's the issues of sprawl, or the lack of monitoring and visibility, and the whole cultural ownership of who actually has the key, what are they doing with it. These are all really simple things. It's a simple fix. We just have to implement some controls around it. Yet, a multitude of organizations don't. I've been in Vegas. I was in Vegas for 9 days. I'm still alive. Only just. Been in Vegas for 9 days. I've been talking to a lot. I knew I was going to do this talk. I was talking to a lot of people out there, people in the class I was teaching, other instructors, the faculty lead, for example. And I asked a lot of the questions about, how do we actually manage root user accounts? How does your organization manage root user accounts? And the response was horrifying, because 90% of them went, I don't really know. Yeah, it's in a password manager somewhere. That's it. Now, emergency access mismanagement is also another problem, because we tend to utilize by default the cloud platforms managed roles. They go, oh, here's a security admin account profile. Use this as your security admin user. Well, it's fine. Apart from that, the permissions against that user are actually massive. They're really permissive. And if an attacker gets hold of one of those accounts, game over. And in fact, this happened. I was on a phone call about 2 hours ago, and I was talking to a friend of mine who is a cyber threat intel agent for a massive organization. And he contacted me and he went, do you know exactly how so-and-so breached this organization? I was like, I've heard of rumors. He was like, actually, they used a break glass account. They logged in as an administrator. They logged in as a limited access user. They passed the infrastructure. They looked around all the different accounts. They made a note of some of the details on those accounts from address lists. And then they contacted the service desk and went, I'm an administrator. I need access to this account. I can't log in. And they reset the password for him. The attacker was then in, and because they had security admin level of account, they had access to the entire subscription-based platform and the Entra services. That's terrifying. That shouldn't be able to happen. With a little bit of control, we can easily make it better. There is one other major issue with break glass, with emergency access accounts, and root accounts in particular. MFA. Now, MFA is great. I wholly believe that, as long as you pick the right version of it. Anything sort of less than FIDO or challenge prompt is vulnerable. So we should be utilizing good mechanisms. We utilize things like YubiKeys. I've got 3 of them around my neck. Carry them with me constantly because servers won't start up without them. But YubiKeys are great because they're a physical token that can't be cloned. Yet they can't be cloned. So you always end up with one person owning the key. I'm going to talk about a little bit about how we strategize for break glass and these kinds of services. We've got the shared access challenges. We've got the issue challenges where MFA is not available, or we put our root accounts or our break glass accounts outside of our MFA policies. Therefore, we don't need them. And if there's a problem with MFA, it means we can still get into our system. Honestly, incident handling and dealing with an organization who've been breached, where the first challenge is to break into the systems in order to be able to manage it, adds a lot of time to the recovery process. An insane amount of time. So what are the common solutions? Well, these tend to vary. There's and by the way, this is an abusive use of AI to generate these images. Everything that's in here that's been image-wise has been generated by AI. I love it. There's one little horrible issue in one of the images as well. See if anybody spots it. One of the most common ways is what we call the power of 2 method, or split control. This is where one party holds the username and the password, one party holds the key, the MFA token, whether it be a hardware token or a software token. Now, this does require 2 people to be in the same place at the same time in order to be able to use those keys. But yet we've got distributed workforces. Half of the people I work with are based in the US. I live in a tiny little hamlet. It's not even a village. I live in a tiny little hamlet in the middle of the North Yorkshire moors in England. So if I need to get to the same place as one of my team in order to utilize a break glass key, it's literally a 2,500-mile flight and nearly 15 hours. There's a lot of organizations work like this in the States. It does prevent misuse of those keys because you have to have 2 people there at the same time in order to use them. An extended method of this is what we call the escrow method, where you use a third party like lawyers or solicitors who actually hold a portion of the key or a portion or the MFA token again. So again, it's the power of 2 used in regulated environments. But this can take time to get access to the key. It's a very strong method. But if you're in an emergency and it's 3 o'clock in the morning and everything's on fire, you need to be able to log into those accounts, and utilizing an escrow mechanism to do this, again, problem. It takes time, requires people to be in the same place at the same time. So organizations then tend to fall back to this method, where they have this distributed storage. We'll have a key personnel who will hold the actual key, and then or the password, and then the MFA token or the password is stored in a separate location. And they have to go through an authorization process to get to it. And that can be, they have to pass the three-headed burning dog to get to the safe with all of the keys in. You know, so they've got to carry biscuits with them. But it could be something as simple as they need access to an actual safe in order to get it. The problem with all of these methods is, where's the history? Where's the tracking of it? When was that key actually last used? When was it rotated? Who performed those actions against it? Because all of these techniques and technologies are outside of the cloud platform, there's really limited visibility. I mentioned the roles. The roles are tricky because the cloud providers, and we're really focusing on Azure here, the cloud providers give you a certain number of predefined platform managed roles. Now, this is great to get you started, but should you rely on them? Absolutely not. And there's two very good reasons why. Number one, they can be incredibly overpermissive. They will give you rights to things that you do not need as an incident responder or as a security admin. But not only that, the cloud platform can change them without you necessarily knowing. Now, AWS actually did this a few years ago. They added the permission to the security responder, or as an IR admin responder, to be able to read the contents of S3 buckets. Well, that changes the entire dynamic of that permission. Now, AWS revoked that. They pulled it back quite quickly and came up with reasons as to why, but it's still, well, the problem, that now problem is defined, that the cloud providers can change things and you not necessarily know what change has been made or how that can be then abused. There is a danger associated with these accounts for things like indirect paths. So an emergency admin account or an IR account or security admin account has the ability to interact with virtual machines in every region, by default, in every subscription. So if you can build a virtual machine, you can build a data exfiltration tool. That's not a good way to protect your infrastructure. That's like saying we've put all these controls in place, we have a nice, robust system, and then we've added a couple of these accounts on the side that are outside of MFA, and they can do all of the things. It's bad practice. But by default, the cloud provider is almost going to push you towards this. It's the same with service principals. The hard-coded credentials that effectively bypass all human interaction, multi-factor authentication, but can be assumed by a user. Yeah, big problem. Overreached implicit permissions, transitive trust between accounts. There's a horrible one that came out of Microsoft a little while ago about billing and ownership. Terrible. If anybody wants to know about that one, come and have a chat with me after. So, we're going to get into some of the nitty details. This is the default security admin account from Azure. Now, this is really permissive. Number one, there is Microsoft authorization, policy assignments, policy definitions, policy exemptions, set definitions on all actions. That's create, update, modify, and delete against the entire authorization system. That's basically access to Entra in its entirety and the user accounts within it. There's also things like management groups, read, workspaces, and all workspace services within it. And then Microsoft IoT security and Microsoft security. Well, IoT security and Microsoft security is effectively Defender and Defender IoT, and access to all of it. That is a very far-reaching and broad scope policy. So should we use that by default? No. One that I came across recently, I was doing a cloud assessment for an organization. They were actually using a different version called Security Manager. Now, Security Manager's got an interesting little addition to the end of it that's called Legacy. But at this point, my spider senses were like, haha, this is going to be a problem. And actually, this gives you access to all of the old compute requirements or compute capabilities in Azure, all the classic compute services, classic storage, all these things. A lot of these sit outside the monitoring environments now. So by utilizing this legacy security manager, you actually effectively can mask or build shadow IT infrastructure without anybody noticing. And it's horrible. Can AI fix this for us? Has anybody used AI, any of the GPTs, to create security policies? No? Yes. Cool. Just one. Brave. Brave to do it, brave to admit it. I asked ChatGPT to assess the security admin policy and to create me a more secure version of it with much more explicit and defined roles and permissions. And this is what it came up with. I had to split this into two screens because it's actually quite large. And in all, it's actually not done a bad job. So rather than actually it's giving us overall control, including create, update, delete, etc., it's been very specific and just said, well, actually reads mostly. It's actually specified this as, no, we're not going to give you everything. We're only going to give you the required permissions in order to be able to assess what's happening inside the environment. So we get lots of reads. We've got some identity containment services like the directory services, users update, useful if we need to be able to isolate and change a user account or disable a user account or reset passwords. It's given us the ability to do some VM containment to start and stop virtual machines. It's given us access to some key services as well. But there's a couple of permissions in there that I really disagree with. Really disagree with. And I told ChatGPT this, and it did what it normally does and go, you're right. Maybe I shouldn't have included that permission. Why would a security admin need access to vault keys to read? That's an interesting one, isn't it? Because there's no permission required. I can't think of a situation where a security admin would need to actually read the keys from a vault. They should be able to identify the key fingerprint and the object ID, but not the key itself. Yeah, no, I didn't like that one. Also didn't like that one. Storage account, list keys. Because the permission here is the storage accounts read. That's fine. It means I can see what's in the storage accounts, and I should be able to see the logs from the storage account. But listing the keys is definitely an action that's way beyond the requirements of a security admin. But again, unless you actually dive down into these and have a look, you are going to miss certain functions that exist in here, and I guarantee you the attackers won't. There's one more. There's one more in here that's a massive one. Huge problem. It's created a policy that's going to apply to every single subscription. And that's technically invalid as well. If you put that into, if you actually put that into a policy in Azure, it will apply, but it won't work properly. The scalable scopes for everything would be just /. But / on an assignable scope, such as a security admin policy, is lethal because that's given access to every single subscription and the Enter ID services. That's scary. That's a scary level of access. Definitely don't want that. So if you're utilizing AI tools to create these policies, great, but vet them. I tend to find, build it in ChatGPT, ask Claude to assess it, ask Copilot to assess it, and then ChatGPT to make sure it's valid again. It's really ineffective, costs a fortune, and utilizes insane amounts of energy, but you'll come out with a better policy. So how do we actually handle this? Well, it just becomes about good practice, really. A lot of the cybersecurity is about best effort. It's about putting the maximum amount of effort in with the resources that we have. And we are in a situation in cybersecurity where idealism really doesn't fit into the model. Because if it did, everything would be really secure, but no businesses would make any money ever. So we have to find this kind of middle ground. And from architect's perspective and from engineering perspectives, we'd put in the most controls we can with the resources we have available. And with break glass accounts and with root accounts, we do things like make sure we actually apply effective controls. Make sure the user account, the actual root account is usable. I've seen it before. Someone grabs a user account. Yeah, I've got the credential for it. You got to log in. Password's invalid. How do you reset a root account credential? So the bit of preparation is really key to understanding. In AWS, there is an organization's root management distribution system. As part of AWS organizations, you can actually specify the root account credentials for every account within that organization. How many times have I seen that actually used inside organizations in the last 20 assessments that I performed over the last 5 years? None. Not one organization was using it. It's a really simple tool to use, and it's effective. It's like I'm on a rant. Define very specific IR accounts for projects and resources. You'll end up creating a lot of accounts, but it's fine as long as you monitor them and you manage them effectively. I'd much rather have 10 incident response accounts than one that can just do everything. Because I guarantee if we have one that do everything, someone's misusing it. It's as simple as. And test them. Validate your DR plans. This is a really critical step that organizations don't do because it's expensive, it's time consuming, and it's not got a direct sort of consequence to the business unless something goes horribly wrong, and then all of a sudden it's a massive consequence to the business. We've effectively got to create a circle of trust in organizations. We've got to have people who are critical to the operation. There are people who are trusted because they were employed by the organization, because they're friends with the CTO. That always happens inside companies. But creating this circle of trust is critically important. One of the things that I come up with in order to essentially help organizations or solve this particular problem is I've created a little platform called Resus. And Resus is derived from a service I created 12 years ago, maybe more than that. It was originally called Am I Dead? And it basically sent me a text message every 24 hours, and I had 12 hours to respond to the text message. If I didn't respond to the text message, it sent a key to a friend of mine who had a USB stick. And that USB stick had on it all of my passwords, all the credentials, the 150 odd domain names I own, plus all the certificate services, everything else with it. And he had an IT company as well, and he did the same with me. So between us, we could cover in the eventuality that one of us did something stupid. It's quite high because we work in IT and we're men. We like snowboarding, riding motorbikes, jumping out of airplanes, that kind of stuff. So there's kind of the incidence of, they potentially is quite high. Decided a little while ago they were actually going to make this bigger and better. So in about a month's time, 2 months' time, we're actually going to release this as a commercial platform. And it's called Resus, the Rapid Emergency Secure Unlock Service. And it basically introduces this circle of trust element, but it does it in the same way that we did it with our mobile phone, with the SMS messaging, etc. We don't hold the passwords, you hold the passwords, we just hold the encryption keys to the passwords. And it means that we can effectively delegate, or you as an organization can delegate the credentials for emergency access accounts and for the root accounts without actually having to necessarily trust a single individual to hold those keys. It means that you don't need two people in the same place at the same time. It can be done, all that service can be done electronically. So look out for this. It is coming out very soon. And I hope it helps because this is a massive problem and it's one that I've seen repeatedly over assessments in the last sort of 15 years. I know I'm standing in between you and lunch and I've got like about a minute left. So open to any questions.